Hello. After grading A4, I thought there were a couple of things I needed to highlight for you guys so that you can pay attention to it when you are doing your A6 term project. So, before I get into all of that, I just kind of wanted to highlight something you guys, a couple of you may already have known is that the topics we covered in modules 3 to 5, where we talked about data entry, analysis, and interpretation, these are topics that are, under the domain of statistics. So I was trying to teach you guys about health data and without having to dive into statistics in such a way that might potentially confuse you. But at the same time, I didn't want to teach it in a way that goes contrary to how the language of statistics in such a way that you don't having had some kind of learning in health data, kind of giving you so that let's use for example you take a statistics course someday and you will find some similarities between the things that you've learned in this course and what you're going to be looking at in statistics so that it kind of makes a little bit of sense without being too going well into it. So the reason I'm kind of bringing this up is that I did find in some of your you guys's submissions that some of you were kind of encroaching into statistics a little bit more than this course required, and then in some cases, kind of not really doing it. So I wanted to kind of clear some stuff up so that it makes it easier for you going forward with A6 especially. So first things first is about the importance of using the right data. This is very, very important. The reason is you guys may have already, some of the movies that is shown. You may have you see this scientist in a room, everybody drinking bad coffee and not sleeping and all of that, and they're all punching on their keyboard, and everybody's trying to figure out what's going on. And let's say there's a national emergency, there's a meteorite that is heading for Midtown Manhattan, and everybody's trying to prevent it, and everybody's doing all the typing in. And then suddenly somebody pops out of nowhere and says, "Hey, we have this all wrong. We have we did the calculation wrong. We have the data, blah blah blah." And then suddenly some very smart person goes back onto the keyboard, types in a bunch of other things, and then suddenly the meteorite that was headed for Midtown Manhattan. I don't know if there's any such thing called Midtown Manhattan, but anyway, so that's this video that was heading for Midtown Manhattan. Suddenly kind of divides and goes into the Atlantic Ocean or one of those Pacific Ocean, maybe. So and then crisis averted and everybody's happy that nobody is dying. So imagine that in that case, in the sense that if you have the wrong calculation, the wrong computer, the wrong computation, the meteorite is going to hit Manhattan, and if you have the right calculation, the right data, then it gets averted and goes into the ocean. So that's how data is. If it's wrong, it's wrong. It's not going. There's no point at which you can manipulate it and get it right. You have to change the data in order for you to get the right result. That's just how it is. And the reason I'm saying this is because I left a couple of some students may have seen this comment in their submission where I said this variable has the wrong values. You were meant to give it more than yes or no values, and I said, please pay attention to getting the values right, because this means your chart will be wrong. If your chart is wrong because it contains the wrong data, your interpretation is automatically wrong. You guys may have seen this. I'm wondering why is she being like this? Why is she being finicky about this? Is like I said, if you have the wrong data, your meteorite is going to hit Manhattan. That's just the way it is. In order to get it so that it doesn't hit Manhattan, you have to get your data right. That's just how it is. So Even if you did your charting correctly, or and then you interpreted your chart correctly, your data is wrong. And because your data is wrong, every single thing in there is wrong. So and another thing to bear in mind, and one of the reasons why I'm saying this, is that this happened a lot with this variable family history of diabetes type 2. A couple of students chose to answer in yes or no, while a couple of most students chose to do the five distinct values. I want to say this now, that pie chart one, which is the one on the right hand side, is not the same as pie chart two. They are not answering the same question. For one thing, we know from pie chart one that 24.5% of the participants do not have a family history of diabetes type 2. However, we know from pie chart 2 that 9.4% have maternal grandparents that have a family history of diabetes type 2. We don't know that information from pie chart 1. We know from pie chart 2 that 5.7% have siblings that have diabetes type 2. That information is not contained in pie chart 1. So they are not answering the same question, and therefore they cannot substitute for each other. If you are asking the question that if you're asking a question that requires pie chart 1, you cannot use pie chart 2 to answer it. If you're asking a question that requires pie chart 2, you cannot use pie chart 1 to answer it, because that would be using the wrong data. So it's very, very important to pay attention to this and understand that they are not interchangeable. So another thing that I wanted to talk about is as it relates to labeling. So some of you may have seen me leave this comment that says your charts are missing. Please note that charts are meant to be labeled underneath the chart or graph, while the labels for tables go above the table. They must be numbered, like example would be figure one. In this case, you could say proportion of family history of diabetes. And then this is very important that you don't do this in A6. So I went ahead and made a correction to one of the students, whereby you saw me change that up. So you see their chart, and then this is my suggestion when I said figure one, overall weight loss by type of dietary change. So what she had initially was line chart showing number of pounds lost in 24 months by type of diet, right? And I made a suggested change that says figure one, overall weight loss by type of dietary change. So just to explain to you that this is what your labeling should have looked like versus the other one. So always remember, the label for your charts go underneath the graph and are meant to be numbered, like figure one, figure two, and figure three. And when you are doing your results for your A6, you need to be referring to figure one, right? In A4, your interpretation were right underneath the charts. In A6, your charts are not going to be in the same place as your results. So you need to be referring to your chart or to your table. If you haven't labeled your chart or your table appropriately, you will not be able to refer it in such a way that someone will be able to go back to your chart and have a look at what your chart is saying and try to make sense of what your interpretation is or what your result is. So that is one of the reasons why it's important to appropriately label your charts and your tables. So remember, labeling for tables go above the table, labeling for graphs or charts go beneath, underneath the charts. Now, lastly, let's talk about how to appropriately interpret your results. So, this is an example of a uh, good interpretation. So, as you can see, one of the bullet points says the highest diabetic family history is shown as being non-insulin dependent. It's very easy to tell because this bar is the highest of everything. So you can see this information that is in this interpretation aligns with the information that is in the graph. And then it says the lowest diabetic family history is shown to be hypoglycemic glycemia. You can also see that this interpretation very much aligns with the information that is in the chart. I'm going to show you an example of an interpretation that wasn't done appropriately. This is an example. And I said, one of the comments that I made said, your data did not measure this. So that is the charts that they have. And in one of this, the one that I highlighted, it says at 18 months, cycling comes in at a close second to burning the most calories. That is not the information that is in the chart because the data did not measure calorie burn. It was strictly looking at weight loss by physical exercise. It did not look at calorie burn. So you cannot extrapolate that information beyond what the data is given. You can't make that interpretation from this because that's not what the data is giving at all. And then the other one says at 24 months, your best weight loss is to get on a running regimen for best results. Also, that is not what this data is showing. That's not what it's showing. So you want to, as much as possible, just stick to saying what the data is saying. It's saying that those who lost the most weight did it at running, and this was at 24 months. They lost more weight than at 6 months. That's as much as that. Trying to go beyond what the data is saying is kind of overextending yourself. And at this level of data interpretation that we're doing is kind of too much extrapolation. So try to avoid that. Kind of stick to the information that is in the chart. So this was not a good interpretation. Now, this is a good interpretation. The reason that I added it, however, even though there was a suggestion that I made with the interpretation, was not because the interpretation was wrong, but because it needed to be edited a little bit so that it is better. So the pie chart is showing values and percentage of participants, but the way that it was written initially, the way that it was written says the largest percentage of participants with type 2 diabetes in their family history was 30% from their father. Now, that sentence can be read in different ways. For me, who is kind of gotten used to reading statistical language, when I read it, what I thought was that she was sorry, is it she? I'm sorry. She was focused on looking at the information about people who have diabetes, not that this data was being interpreted for everybody. So for me, reading that, I was like, that's not what that's not what this data is measuring. So that's the reason why I changed it up and suggested to say 30% of participants reported their father has diabetes type 2. Much straightforward and leaves room for less confusion. So try to make your sentences as straightforward as possible, leaving less room for confusion so that this way is pretty very easy to understand. So I hope this is helpful. I believe this is the last slide. Yeah, it is. So I hope this is helpful for you guys in terms of completing A6. If you still need me to explain some things that I already explained here, please let me know. And if need be, I will do another video for it. All right. Do have a lovely day. Bye.